Hello, welcome to IT Expert YouTube video series. Today we are going to talk about Hadoop explanation in 15 minutes. What is Apache Hadoop? Apache Hadoop provides an open-source framework that enables the distributed processing of large data sets across clusters of compute resources. Its design can scale from single servers to thousands, each offering local compute and storage capabilities. Hadoop was born out of a need to process increasingly large volumes of big data and was inspired by Google's MapReduce, a programming model that divides an application into smaller components to run on different server nodes. Unlike the proprietary data warehouse solutions that were prevalent at the time it was introduced, Hadoop makes it possible for organizations to analyze and query large data sets in a scalable way using free, open-source software and off-the-shelf hardware. It enables companies to store and process their big data with lower costs, greater scalability, and increased computing power, fault tolerance, and flexibility. Hadoop also paved the way for further developments in big data analytics, such as Apache Spark. Hadoop Architecture. The Hadoop architecture is a package of the file system, MapReduce engine, and the HDFS Hadoop distributed file system. The MapReduce engine can be MapReduce MR1 or Yarn MR2. A Hadoop cluster consists of a single master and multiple slave nodes. The master node includes job tracker, task tracker, name node, and data node, whereas the slave node includes data node and task tracker. Why is Hadoop useful? The explosion of big data and data collecting devices throughout business operations offers companies significant opportunities to innovate and succeed. Because Hadoop detects and handles failures at the application layer, rather than the hardware layer, Hadoop can deliver high availability on top of a cluster of computers, even though the individual servers may be prone to failure. What are the benefits of Hadoop? Hadoop has 5 significant advantages that make it particularly useful for big data projects. Hadoop is 1. Scalable. Because it can store and distribute large data sets across hundreds of inexpensive servers that operate in parallel, Hadoop is highly scalable. Unlike traditional relational database management systems (RDBMSs), Hadoop can scale up to run applications on thousands of nodes involving thousands of terabytes of data. 2. Flexible. Hadoop can tap into both structured and unstructured data to generate value. This allows businesses to derive business insights from a variety of data sources, such as social media channels, website data, and email conversations. In addition, Hadoop can be used for purposes ranging from recommendation systems, log processing, and data warehousing to marketing campaign analysis and fraud detection. 3. Cost-effective. Traditional RDBMSs are extremely cost-prohibitive to scale enough to process big data volumes. Companies using such systems previously had to delete large amounts of raw data, as it was too expensive to keep everything they had. In contrast, Hadoop's scale-out architecture makes it much more affordable for a company to store all its data for later use. 4. Fast. Hadoop employs a unique storage method based on a distributed file system that maps data wherever it is located on a cluster. Plus, its tools for data processing are often on the same servers where the data is located, allowing for much faster data processing. Because of these features, Hadoop can efficiently process terabytes of unstructured data in minutes and petabytes in hours. 5. Fault tolerant. Data stored on any node of a Hadoop cluster is replicated on other nodes of the cluster to prepare for the possibility of hardware or software failures. This intentionally redundant design ensures fault tolerance. If one node goes down, there is always a backup of the data available in the cluster. Hadoop makes handling large data sets safely and cost-effectively much easier as compared to RDBMSs. And its value for a business increases as the amount of unstructured data that the organization possesses grows. Hadoop is well suited for search functionality, log processing, data warehousing, and video and image analysis. Hadoop interview questions for freshers. 1. Explain big data and list its characteristics. Gartner defined big data as Big data is high volume, velocity, and variety information assets that demand cost-effective, innovative forms of information processing for enhanced insight and decision making. Simply, big data is larger, more complex data sets, particularly from new data sources. These data sets are so large that conventional data processing software can't manage them. But these massive volumes of data can be used to address business problems you wouldn't have been able to tackle before. Characteristics of big data are: volume. A large amount of data stored in data warehouses refers to volume. Velocity. Velocity typically refers to the pace at which data is being generated in real time. Variety. Variety of big data relates to structured, unstructured, and semi-structured data that is collected from multiple sources. Veracity. Data veracity generally refers to how accurate the data is. Value. No matter how fast the data is produced or its amount, it has to be reliable and valuable. Otherwise, the information is not good enough for processing or analysis. 2. Explain Hadoop. List the core components of Hadoop. Hadoop is a famous big data tool utilized by many companies globally. Few successful Hadoop users. Uber, the Bank of Scotland, Netflix, the National Security Agency of the United States, Twitter. There are 3 components of Hadoop are: Hadoop Yarnet is a resource management unit of Hadoop. Hadoop Distributed File System HDFS, it is the storage unit of Hadoop. Hadoop MapReduce, it is the processing unit of Hadoop. 3. Explain the storage unit in Hadoop. HDFS is the Hadoop Distributed File System, is the storage layer for Hadoop. The files in HDFS are split into block-size parts called data blocks. These blocks are saved on the slave nodes in the cluster. By default, the size of the block is 128 megabytes by default, which can be configured as per our necessities. It follows the master-slave architecture. It contains 2 daemons: data nodes and name. Node. Name. Node. The name node is the master daemon that operates on the master node. It saves the file system metadata, that is, files names, data about blocks of a file, blocks locations, permissions, etc. It manages the data nodes. Data node. The data nodes are the slave daemon that operates on the slave nodes. It saves the actual business data. It serves the client read-write requests based on the name node instructions. It stores the blocks of the files, and name node stores the metadata like block locations, permission, etc. 4. Mention different features of HDFS. Fault tolerance. Hadoop framework divides data into blocks and creates various copies of blocks on several machines in the cluster. So, when any device in the cluster fails, clients can still access their data from the other machine containing the exact copy of data blocks. High availability. In the HDFS environment, the data is duplicated by generating a copy of the blocks. So, whenever a user wants to obtain this data, or in case of an unfortunate situation, users can simply access their data from the other nodes because duplicate images of blocks are already present in the other nodes of the HDFS cluster. High reliability. HDFS splits the data into blocks. These blocks are stored by the Hadoop framework on nodes existing in the cluster. It saves data by generating a duplicate of every block current in the cluster. Hence presents a fault tolerance facility. By default, it creates 3 duplicates of each block containing information present in the nodes. Therefore, the data is promptly obtainable to the users. Hence, the user does not face the difficulty of data loss. Therefore, HDFS is very reliable. Replication. Replication resolves the problem of data loss in adverse conditions like device failure, crashing of nodes, etc. It manages the process of replication at frequent intervals of time. Thus, there is a low probability of a loss of user data. Scalability. HDFS stocks the data on multiple nodes. So, in case of an increase in demand, it can scale the cluster. 5. What are the limitations of Hadoop 1.0? Only one name node is possible to configure. Secondary name node was to take hourly backup of metadata from name node. It is only suitable for batch processing of a vast amount of data, which is already in the Hadoop system. It is not ideal for real-time data processing. It supports up to 4,000 nodes per cluster. It has a single component job tracker to perform many activities like resource management, job scheduling, job monitoring, rescheduling jobs, etc. Job tracker is the single point of failure. It supports only one name node and one namespace per cluster. It does not help the horizontal scalability of name node. It runs only MapReduce jobs. Thank you for watching this video. We provide hands-on training with labs, homework, group projects. Prepare you for the certification. Provide real projects. Internship opportunities. Support you in resume LinkedIn. Staffing support. Provide tech references. In-person online class. Class retake options and more. Call us at 847-350-9034 for your free career consultation meeting. Please do not forget to like, share, and subscribe to our channel for the latest videos.